Hello, Algebra 2 students. We're going to start 5-4, analyzing graphs of polynomials. So you probably want to have your graphing calculator handy. If you don't have a graphing calculator, so you want your graphing calculator. Or you could use Desmos if you don't have your graphing calculator. But yeah, you're going to need one of those to do the activities in this video. So we can graph polynomial functions and find their zeros, and we can also find the relative maxima and minima of polynomial functions. So location principle is what we're going to be talking about. And we've kind of done this before. So when we're finding zeros, we want to find what two whole numbers, the zeros in between. So if f of a is less than 0, and f of b is greater than 0, then we know that our 0 has to be in between a and b. We've kind of gone over that before. So for example, when we graph this, and you guys can go ahead and pause the video and do this on your graphing calculator if you would like. We're trying to find zeros. We're trying to find the whole numbers that our 0 is in between. So if we look here, if we look at our table, we notice the change in the sign. It goes from -7 to +1. And so we know our 0 is going to be in between -1 and 0. Okay, so we have that. And we have another change in the sign. We go from 1 to -1, so we know our other 0 is going to be in between 1 and 2. And we have another change in the sign because we go from -1 to +1, so we have 3 zeros here. So how we would write our answer, just how we said it, it's in between. We have one x that's in between -1 and 0. Between 0 and 1, or excuse me, 1 and 2. And then we have another one in between 2 and 3. So that's where our zeros are. We're always looking for the change in the sign. So here's the next one. I want you guys to go ahead and try this on your own. Again, use your graphing calculator or use Desmos.com. So pause the video, type this in, see if you can find the real zeros, what the zeros are in between. So I went ahead and typed it in. Now I'm looking at my graph here. And if you notice, it's in between 0 and 1. And it's also in between 3 and 4. Between here. So that would be my answer for this. And you can look at your table as well. So we said between 0 and 1 and 3 and 4. So we have 2 zeros for this one on our Desmos. Alrighty. Okay, the other part is we're talking about relative maximum and minimum. So pause the video, write these notes down, or read through them. So the relative maximum is increasing as it approaches A, so it's increasing left to right and decreasing after it moves away from A, left to right. And there's no nearby points that have a greater y coordinate. The relative minimum decreases as it approaches B, and it increases as it goes away from B. So we're always going left to right. The max and min are also called the extrema. So that's another vocab word for you. These points are also known as turning points. So if the degree of the polynomial is n, then it has at most n turning points. It has at most n turning points. And I would want to change that actually. I was like, wait a minute, that doesn't sound right. It should be n minus 1 turning points. I was going to say. Otherwise, that'd be incorrect. So n minus 1 turning points. So we know this could be this could be to the third power because we have 2 turning points. So I want you to graph f of x, x to the third minus 4x squared minus 2x plus 3, and find the max and the min, the maxima and the minimum of this. So when you graph this, this is what your graph should look like. And then I have the table. Your table should also look like this. So now we can find the relative max and minimum. So when we do that, and we can find zeros as well. We have a 0 right here, because that's pretty obvious. F of x is 0, so we have a 0 right here. And this right here would indicate 0, 3. This would be a max, a relative max, because if you notice, the y-coordinates around it are less than that. So this would be the highest, the greatest y-coordinate, so that could be a relative max. And can we also find another max or min? We have a max up here. We should have another min or one minimum. And we can find that by looking at here. If you notice right here, and we probably should put relative. It's a relative min, relative max. So a relative min would be right here. This would be a relative max. Because if you notice, the y-coordinates on either side are higher, okay, are greater. So it's a relative min. And we should be able to find another 0. A couple, actually 3 more zeros here. If we could. Except for on my table, it probably doesn't show it, does it? Well, kind of. Yeah, in between 4 and 5. Here we go. We got another 0 here. In between 4 and 5. And we had another one here, -1, 0. And there's another one between, is in between 0 and 1? Yeah, here's another 0. In between 0 and 1. Alrighty? So lots of things that we can see from the graph and the table. But we're really focusing on the 0, the max and min. And yeah, look at your graph, see where you're going to be looking at your table. And yeah, and we also know how to do that on our calculator using the calc function, which we'll kind of practice in class as well. That's coming back. Another thing, just another visual for you to look at, increasing and decreasing. We're always going left to right. So think about that. And in the Google form, go ahead and submit what you think the zeros are. All I want you to do is focus on the zeros. So what are they between? Okay, finding the zeros for this function right here. Alrighty, thank you very much and have a good weekend, and we'll see you on Tuesday after Martin Luther King Day. Adios.